Welcome to Kotlin. In this video we're going to look at two popular architectural patterns, MVVM and MVI. We'll see how they compare in an Android or Compose multi-platform app. We'll build the same screen using both approaches and break down the benefits of each. Here's the basic setup. If we look at the completed app, this is what it's going to look like. We have a cat repository set up that loads a list of cats. Within here it also allows you to favourite a cat, which will remember whether it's been favourited. We have a cat item already set up, so we can see here from the preview this is just what it looks like, and we have created a nav host that just goes to three different screens. We have an MVVM1, MVVM2, so these are just examples, and an MVI screen. These are just currently empty. MVVM stands for Model, View, View Model. It's a design pattern that helps separate concerns in your UI architecture. Each part has a distinct role. The model is responsible for your data and business logic. In our case, that's the cat repository. It provides data and handles operations like toggling favorites. The view model acts as the middle layer. It exposes UI related data, usually through observable flows, so state flows or live data, and also handles user actions coming from the UI. It doesn't reference the view directly. Instead, it provides data the view can collect and react to. This makes it testable but also lifecycle aware, especially when using Android's view model class. The view, in this case, is our composable. It observes data from the view model and renders the UI. When the user interacts with it, such as typing in a search box or clicking a button, the view calls functions on the view model to update the underlying state. The key idea here is that the view model holds the state and the logic to transform that state, but not the UI itself. The view just reflects the state and it never directly handles data or logic. This clear separation makes your code easier to test and maintain. In Jetpack Compose, MVVM works really well because Compose is inherently reactive. Whenever your state flow or live data emits a new value, the UI recomposes automatically, keeping everything in sync. First, we'll start by creating all of the fields we need for our screen. The idea here is that the public val, so in this case cats, this will be a state flow and this is not mutable, where we'll have a private backing field of the flow which is mutable. For the set of which cats are favorited, we'll use our observe favorites function in the cat repository. Hopefully it's clear enough what each of these properties will do, but it should become more apparent once we actually create the composable. So coming back to our composable, we should now be able to access each of these properties we've just created. We can do that using the by delegate. So in this case, viewModel.cats. We can use collector's state with lifecycle. Now we'll do this for each of the properties. Now I'm going to create the UI. I'm going to speed this up because this episode isn't really about how to create something using Compose. Once I've finished, I'll briefly talk through everything that's there. So taking a look at the completed version of the app, we'll just compare the UI to show what's what. So if we look at this row here, this matches up with this text field, and the icon next to it is what we're going to click to toggle between a grid view and a lazy column. Next, if it's loading, it's just going to show a circular progress indicator, And if it's grid view, we'll use a lazy vertical staggered grid, otherwise a lazy column. And each of the items here are the cat item composable previously mentioned. And at the bottom, we've simply got, if you click to select a cat, it's just going to show an alert dialog with the information about that cat. So one thing we now need to do, if you'll notice, a lot of these on-click parameters are just currently doing nothing. We need to create corresponding functions in the view model and hook them up. So we'll do that now. So within here, we'll call view model dot close detail, and this will be exactly the same for in on dismiss request. We're going to create these functions in a minute. Now here we'll call view model dot favorite toggled, and within here we'll pass the cat that's coming through part of this callback of the cat item composable. And this one we can call view model dot, we'll name this on cat clicked. Similarly, we'll pass through the cat. Now I'm just going to copy these for this cat item. Now up here, when we click the button to toggle between the grid view or the regular lazy column, we'll call this toggle view type. And lastly, when the text field value changes, we'll call view model dot filter changed and pass in the new string. So we'll jump back over to the view model and we'll actually create these. The first one we had on cat clicked, and we had favorite toggled, filter changed, and that took in the string, toggle view type, and close detail. So now we can actually implement these functions. So each of these are just going to affect these properties in some way or another. So on cat clicked, this should be a simple one. Our selected cat, we'll just update the value to be the cat that's passed through. Now the favorite toggled, we can call cat repository dot toggle favorite and pass in our cat. For the filter changed, all we need to do is update the value in the backing property. Now is grid view, we just need to invert this. And close detail, we can just set selected cat to null. So one last thing we need to do, you may have noticed, but we're not actually using this filter anywhere. We're not filtering our cats, or we're also not even getting our cats from the repository. So we'll do that in an init block for the view model, and we'll call view model scope dot launch. And the first thing we're going to do is set is loading to true, because we're about to start loading the cats. So now we can use combine. So for two flows, we'll use cat repository dot get cats, and we'll also pass in our filter text. So in here, that's what we'll get. We'll have cats and our filter, and now we can actually filter the cats. So cats.filter, we'll just say if the name of the cat contains our filter, so ignore case equals true. Now we can collect this. We'll name this filtered cats, and we can set cats.value is equal to filtered cats. So now this is going to be collected every time the cat in the repository changes or the filtered text changes. But one last thing we'll do is we'll say is loading.value equals false here, because at this point you've now loaded the cat. So I've run the application, and as you can see, it all seems to be working. We click through, the functions to the view model are working, so is the filter, and we can toggle between the views. So this view model's passed straight into the composable, and as you can see up here, we're getting the view model just by using remember. In a real world application, this will most likely be retrieved using Hilt or Coin or some other dependency injection library, because this will most likely have dependencies that need resolving. In our case, we're just using a singleton for simplicity's sake. So passing the view model directly in, this is where we see our first drawback of using MVVM, but how we can also mitigate this. So the drawback is that there is not an easy way. So if we wanted to add a preview, and we want to use this composable, this needs a view model. Now, it might be simple enough in our case to just create the view model because it has no parameters, but imagine if we had, well, however many dependencies, they need resolving somehow, and ideally you don't want to be doing that inside of a preview. So we're going to look how we can slightly improve this to not only make it so we can preview our composables, but we can also then easily write UI tests for them. So moving on to our second example, I've copied all of the code from our first view model because this is going to be exactly the same. Inside the screen file, I've added all of the fields from the view model, but this is where things will differ. So what we're going to do is create a composable that's completely agnostic to anything like view model. All it's going to do is take in parameters of what needs to be displayed and provide callbacks for when things are clicked or text's changed, anything that needs a callback. So here I'll call this catlist screen content and fill in the parameters that we need. So we'll need a list of cats, whichever cat is selected, whether it's loading, basically just these fields here. And what we're also going to do is add the callbacks. So these are just going to match the functions that are inside of here. So our first one was on cat clicked, and that provides a cat. On favorite toggled, then we had on filter changed, so for the text field. When we toggle the view type, and for when we close the detail, so for the alert dialog. And we're also passing a modifier. So now in this composable, where we're passing in the view model, we can now use this. So the first 6 parameters are simple enough. It's just going to match what's up here. Just going to rename this to selected cat. And these callbacks, we should have our matching view model functions. So we've got on cat clicked, favorite toggled. If you're wondering what these two colons are, this is just accessing the function directly. It's exactly the same as doing, in this case, filter changed and passing through our string. We can either do this or with the two colons. And we'll just use the default modifier. Now I'm just going to go back to our first screen and copy the composable code, and we'll paste this into our content composable. Now there's a few changes we need to make. So instead of calling view model here, we'll just call on filter changed, on toggle view type, on cat clicked. So there's a matching function for each of these. And we'll actually use this modifier that's passed in. Now we're just going to run this and check everything's working. So this will be MVVM Example 2. Yep, and as you can see, it's all still working. It functions exactly the same as our Example 1. But now we have the benefit of being able to test, well, write UI tests and also preview this. So we'll write the preview now. So here we'll call our content composable. Specify all required arguments. So now here we'll just pass a list of some cats. Just name this test cat and test description. We'll add another cat, name this Brian. Test description 2. Selected cat is null. So it is loading false. No filter text. Grid view false. Empty set for the favorites. Now each of these callbacks we can just have empty code blocks. They don't need to do anything, and we don't need to pass a modifier. I'll just close out of the emulator, but importantly now we can rebuild the project and we should be able to see the preview. Yeah, so we'll just add a modifier for the background so we can see this a bit more clearly. Rebuild, and yeah, as you can see, we can now preview our content for the screen. MVI stands for Model View Intent. It's a unidirectional architecture where the UI is driven entirely by a single state object, and all user actions are performed through events. The reducer, in this case our view model, updates the state based on these events. Although MVI isn't tied to Android's view model, we're still going to use it. This is because Android's view model gives us lifecycle awareness, state survival across configuration changes, and we also get access to a coroutine scope tied to its lifecycle. The first thing we need to do is represent all of these flows in a single state object. So we're going to create a data class named catListState, and in here all of these fields we're going to put into this single state object. We've set initial values for each of these properties so that something can always be displayed on screen. The next thing we'll want to do is create an event class which is going to match each of the events that can happen. These events are actions that are performed by the user. So we'll do that inside of a sealed class named CatlistEvent. Now it's important here to inherit from the sealed class itself. This is so that when we use a when statement we can make it exhaustive and use one of these classes. And for when we're toggling the view type, this will not have any parameters coming into the any properties for the event class, so we can just use data object here. So now we can actually pass the state into our screen composable and also a callback for the events. So if we go into our screen class, we can add a few parameters to this function. The first one will be the state, and the second one will be a callback that we'll name onEvent. That will have the event as a parameter of the function and return a type of unit. We'll also pass a default modifier through. So now you can see here when we're actually using the screen, we need to add the parameters through here. So we're going to get the state through a view model. So here, well, we'll create our view model first. So just within here, we'll name this Catalyst MVI view model. This is just so we can differentiate it from our other view models. So this will inherit from Android's view model. Now this is just as said earlier, so our state can survive things like configuration changes, and we're just going to store this state in a mutable state flow, sorry. So we'll give this a default value. So next we'll expose that through a public file using state.asStateFlow. Now if we come back to here, we'll get our view model. In this case, just for the example, we're just going to use remember and just initialize the view model as so. Now we can get the state by using by viewModel.state.collectorState with lifecycle, and we can pass this straight into the function, into the composable. Now for the onEvent callback, we want to forward this through to our view model. So if we come back to the view model, we'll create a function, we'll name this sendEvent, and this will take in a catalyst event. So this matches the function signature of this callback. So we can just use viewModel : sendEvent. We could do it like this, or we could say viewModel.sendEvent, and we'll get the event as a parameter of this lambda. Now if we come back to this sendEvent function in the view model, we'll use a when statement here and say when event, and because this is a sealed class and all of these inherit from CatlistEvent, this is now exhaustive, so we can just generate the remaining branches and we don't need an else because this CatlistEvent can only ever be one of these types. So the idea here is that this function is deterministic. So this means that given any specific state and any specific event, it will always produce the same next state. Or to put it another way, it means that for any given current state and incoming event, the resulting state is always going to be the same. The reasons why this is important is because it's going to produce predictable behavior. You can trace exactly how and why the UI ended up in a certain state. It makes it easier to test because, given a known input, so that's the state in the event, you can assert the output in your test, and you're easily able to keep a log of the history of states. In some cases, it's even useful for implementing features such as undo or redo or reset to a previous state. So for example, with our cat clicked event, this is quite a simple one. All we're going to do is state.update, and we'll create a copy of the current state, and we'll set our selected cat to the cat that is passed through this cat clicked event. So we can use event.cat. Now our close detail, so this is closing the detail alert dialog that's shown when there is a selected cat. So we'll copy this. The difference being this is just going to be set to null. When the favorite is toggled, we'll use our cat repository and call toggle favorite, and we can pass through the cat from the event. When the filter's changed, we'll just update that within the state. So that will now use event.text. And the toggle view type, similarly, we'll use state.update, and we'll invert is grid view. So that's now inverted. So there's a couple of things left that we need to do. If we come back into our MVVM view model, you'll remember that we're getting our favorites through the cat repository. So it's slightly different when we're doing this here because it's just a property within cat list state. So to get that, we'll use an init block, view model scope dot launch. We can use cat repository dot observe favorites, and collect the latest from that, and simply just update the value within state. So we'll create a copy of the current state, but pass in the favorites. And coming back to the view model, if you'll remember, we needed to actually filter the text. So we'll use view model scope.launch again. And the first thing we're going to do is just update the state, but set is loading to true. And then similarly to what we did in the MVVM view model, we can use combine. We'll have cat repository.getCats. Now, looking back in the MVVM view model, we had the flow up here that we could pass directly into combine. We can't do that directly with this because our flow is a state. So we don't want this to be triggered whenever the state changes. We only want it to be triggered when the filter text changes. So to do that, we can use state.map, map this to filter text, then we can use distinct until changed. So now this will only be affected when either the cat repository cats changes or this filter text changes. So here we'll have cats and the filter. Now what we're going to do here within this block is create the new state that we want to set. So we'll do that based on the current state. So we can use state.value.copy, say the cats is equal to cats.filter, and this is just going to be the same logic as in the MVVM view model. And we're also going to set is loading to false. So this is producing a new state, but we need to now collect this. So we'll use collect latest, and in here we can just say state.value equal to it. So now we just actually need to add the content into the screen composable. So we'll go to our old screen, and we just want to take everything from inside catalyst screen content. We'll just copy that and paste it into here. Now there's a few things we'll need to change, so everything is coming through our state parameter now. So we can just add state dot in front of a lot of these things. Now when the callbacks were used in the content composable, this is where we now need to use on event and pass through catalyst event dot and whichever corresponding event we have there. So in this case it's filter changed. So here we should have a toggle view type event. This will be state dot is grid view, state dot is loading, and so on. I'll speed this up. Okay, so we've added everything now, so we'll just run this and see how it looks. Yep, so as you can see, everything's working exactly the same as in the MVVM examples. So one last thing we'll show for this is how easy it is to preview a composable that takes in a state. We'll use preview. So here we're going to use our catalyst MVI screen composable, and we'll pass in our state. We'll just give a test cat. And within on event, we can just have this as an empty code block because we don't need to do anything with the actions performed by the user. This is just a preview. And modifier, we're just going to add a background so it's nicer for us to see in the preview. So we'll build this and take a look. And as you can see, the preview looks completely fine, and we can just add whatever we want into this state here. We'll just add a second cat. And it will update. So you're probably wondering now, which one should you use for your project? And the answer is, it doesn't really matter. MVVM is familiar, it's easier to onboard new devs and works perfectly along with any existing Android tooling. It's great for smaller screens or when you want to stick with the official approach that Google recommends. MVI adds a bit more structure. It simplifies parameter management, encourages immutability, which is quite important for Compose, and it makes event handling predictable. So it especially works well with Compose because of the UI just recomposing based on this single source of truth. So it's the state class that we mentioned. If you value clean separation and scalability, MVI might be the better fit, but both are valid, both are great. Just choose the one that fits your needs and your team. If you all have experience using MVVM, there's definitely no need to switch over. Let me know in the comments which your team uses, MVVM or MVI, or something completely different. I'm always curious to hear because I see a lot of both used nowadays, and it's sometimes hard to tell which is more common. If you've made it this far, I just want to say thanks for watching.